Hello all, welcome to today's video. Today we'll be discussing about threads. Threads, as you all know, is a means to paralyze the work being done so that we can achieve the results much more quickly. Therefore, we have used threads. We might have used threads in our applications in many places where we want to do some set of functionalities in a parallel manner so that we can get the results much more quickly and the application runs much more faster. Therefore, here we will be discussing about two kinds of threads actually. One is called the foreground thread and the other one is the background thread. I will be taking a C sharp example for our study. So we will be looking at some C sharp example, what is meant by foreground and background thread. We might have we might have all used or created threads in some form or the other. Either we have used the thread class in itself, thread library directly, or we might have indirectly used the thread library through task. So here I'll be using the thread library directly to explain what is the difference between the foreground and the background thread. For this is the post from my blog. Actually, I will just pin it in the comment section, the link to this post, and you can go through it and try to follow it along. So before going into details, I would like to request that everyone subscribe to this particular channel and do share with your friends if you like this particular video. Yeah, going on to our topic. First, we will discuss about foreground thread. Therefore, these are the threads which are created by default. So by default meaning whenever you use the thread class and you create a new thread, by default it is a foreground thread. Therefore, what is the specialty of this thread? Therefore, these threads run until its task get finished and is not dependent upon any other thread. For, therefore, the foreground thread has the ability to run independently of other threads. Therefore, it doesn't have any dependency or lifetime dependency on the other thread. By dependency here, I mean the lifetime dependency or how much time that particular thread leaves. That dependency is not there for foreground thread. Therefore, in other words, it can be said that the application is kept alive until all the foreground thread completes its execution and terminates. Therefore, application, whenever a particular exe will be kept alive until all the foreground threads are active. If all the foreground thread dies, that means that application also dies. That in simple words, we can say like that. Therefore, why it is used, why the foreground threads are used, on which context these foreground threads are used. Therefore, these foreground threads are mainly used to perform application critical tasks such as processing of the application data. Why critical task? Because we have already said that this foreground thread lifetime will be the application lifetime, and its life there is no lifetime dependency of the foreground thread on any other thread. So that means that the once a task is assigned to the foreground thread, it will get completed no matter what. So once it completes, then only the application dies. So that is why we actually uh, allocate critical task, application critical tasks to the foreground threads. So how to create a foreground thread? If, as I already said, I am directly using the thread class directly, and we can directly create a foreground thread like new thread, and you pass in the delegate, which is the function which is being parallelized, which is being accessed by multiple threads, or which this particular thread is trying to execute, and we are assigning the name of this thread as foreground. We are just allocating a unique name to this particular thread. So by default, if you create a new thread, it is a foreground thread. That's simply, if you just simply put, it is just like if you create a new thread, it is a foreground thread. Then coming to the second thread type, background thread. Therefore, background threads are the threads whose lifetime depends upon the foreground thread of the application which is running. Therefore, we have seen the foreground thread is independent lifetime. There is no lifetime dependency on any other thread. But in the case of background thread, its lifetime depends upon the foreground thread. So if the foreground thread dies, the background thread will die. It is not that the lifetime of the background thread is the lifetime of the application. It's the lifetime of the background thread is equal to the lifetime of the foreground thread. For if all the foreground threads on application exits, then the application kills all the background thread which are running. For once the foreground thread exits, then there is no, then the background thread can't survive. It will just application will kill the background thread while in the exit process. A background thread is mainly used to perform some support operation or bookkeeping operations, such as logging the application activity, which are not run in a high priority because its lifetime can't be predicted because its lifetime mainly depends upon the foreground thread. Therefore, we will just assign some bookkeeping operations in the background thread. Therefore, there is a syntax for creating a background thread using the directly thread clause. When you create a new thread and assign the delegate, and you just set the property is background to true as shown in the screenshot captured. Is background to true, then this thread will become a background thread. There is a property called is background which determines whether the given thread should run as a foreground thread or background thread. By default, the value of this particular property is false. Then I am trying to actually demonstrate two scenarios to actually show how this particular foreground thread and background thread behaves when we run it in an application. We'll just switch to the Visual Studio now and we will just try to see the demo live. We will just try to discuss the two scenarios in Visual Studio. Therefore, that will be much more clearer. Just switch to Visual Studio now. So this is the code which I'm trying to demonstrate. As you can see, this is main function program class, which has three static APIs: print foreground, print background one, and print background two. So this inside these APIs, I'm doing a console write of some text and printing the current thread name, and I'm looping some set of console write that executing print foreground and then sleeping for each execution. In between each execution of the for loop, I'm sleeping for 500 milliseconds. That's what I'm doing it in the all the three functions. I'm doing the same thing, but the print statement will be different. For the second function, background thread, I'm trying to print the background thread information, print background 1, and similarly for print background 2. This is the only difference which is there across the three different static APIs. If you come to the main entry point of our application, which is the main function, I'm creating a foreground thread first. A thread foreground equal to new thread and assigning the delegate to it, print foreground, and assigning the name as foreground, and then creating a background thread 1 as new thread and assigning the delegate print background 1 to it, and setting the is background equal to true. This is very important. Once you want to set a particular thread as a background thread, we have to set the is background property to true in C sharp, and setting the name property also. Similarly, creating the thread background thread 2. Then what I'm doing is I'm starting the foreground thread, I'm starting the background 1 thread and background 2 thread. I'm starting and console write line that main thread exits. This is the last statement that the main thread will print. Therefore, here intentionally I didn't use the join statement for all these threads because once we try to join it, then the main thread will be the last one exiting the application. So I don't want that to happen. I just want to demonstrate the behavior or dependency between the foreground and the background threads, not to the main thread actually. So actually by default, the main thread is a foreground thread, one of the foreground threads. Therefore, here I am starting one another foreground thread manually, foreground dot start. If I didn't use the join here as I for the reasons mentioned before. So I'll just try to what I will try to do is I will try to run this application and show you the output. Start without debugging. Yeah, as you can see, what happened is print foreground is printed one, two, three, four, 5 times, which is correct. And print background is printed one, two. Print background one is printed one, two, three, 4, and 5, which is also correct. And print background 2 is printed one, 2, 3, 4, and 5, which is correct, which is expected. All the print statement executed fine and it was able to print that statements to the console. Therefore, we don't see any discrepancy here. Therefore, we see that the main thread exits here, and after, even though the main thread exits here, it was able to the other threads, the background thread and the background thread one, background thread two, and the foreground thread were able to execute and print the statements in the console even after the main thread exits. That's the main point to note here. And let me try to do one small difference. I will try to make some change to this code. I will try to comment this foreground thread execute. I will not start the foreground thread. Just try to execute the application once again. Yeah, what happened? There is no print statement from background thread 1, background thread 2, even though we are starting the background thread 1 and the background thread 2. We are starting both the threads, but there is no print statement coming. So why is that? So why is this happening? Therefore, one of the reasons why it is happening is only the main thread exists. This is the print statement that we got. No other print statement we are getting. Only main thread exit is the print statement that we got. That is from the main thread. And no background thread was able to continue its execution. Why? Because as we have already discussed, the lifetime of the background thread is dependent upon any of the foreground thread which is running in that application. For once this main thread exits, there is no foreground thread in play. Therefore, hence the background thread 1 and background thread 2 were not able to execute and they were killed by that application. Once that only one, there were only one single foreground thread in play, which was the main thread. Once that once that exits, the background threads were killed, all the two background threads were killed, and they were not able to print the corresponding statements in the console. So that's what happened here. If you try to run this same code again and again, you will see that sometimes the background thread print will come into the console. Why that happens? That happens because sometimes the main thread lifetime will not is not predictable because it is trying to write into the console and can take some time to write it to the console, to write into the console buffer, etc. For during that time, the background thread would be able to execute and write its statement to the console output buffer. For when that happens, it will able to come up in the uh, console. Let's try to run it couple of times. Yeah, this is what I just now said. So as you can see, the background thread 1 and background thread 2 were able to execute only once. It was not able to execute 5 times because while, as I told before, the main thread lifetime is not predictable. It can stay there for some time long enough so that the background threads be able to perform their task uh, some more. It can background threads will able to perform some more tasks and this lifetime of the background thread will be elongated because if you see the printing, the way it is printed, the first main thread exists and then the background thread was able to print it. You don't see this ordering, because ordering will be interlaced, because it is executing into three different threads, and they were able to print access a common resource, which is a console. Therefore, there will be no ordering as such. That ordering will be interspersed. The way it is printed will be interspersed. So if you execute a couple of times, you will see different results. The ordering will be quite different. Yeah, as you can see now, the main thread was able to execute quicker and was able to exit much more faster, and it didn't give time to the background thread to performing any minor task. If, as you can see, there is no print statement from the uh, background threads. For the first scenario, the scenario one is that this foreground thread, when it starts, it stays there. It is running in the detached mode. This foreground thread will run in a detached mode, and it leaves there. And there is no join, since there is no join statement. It leaves there in that application, and therefore the background thread will get enough time to perform that task. Therefore, it will not be killed unless and until we kill the application. So that's what is happening here. Once we comment out the foreground thread, there is only one foreground thread, which is the main thread in play. If a main thread exits, and there is no scope for the background thread to execute this functionality. But in the first scenario, where we have a separate foreground thread, it is executing its job. By the time the background thread will also get time to execute its job, because there is one foreground thread in place, even though the main thread exited previously beforehand itself. So that's the main thing to note about this foreground and background thread. Main thing to note here is the lifetime dependency of background thread with the foreground thread. That is the main point. That should be the takeaway from this particular video. Therefore, that's it I want to cover in this particular video. Again, thanks for joining, and do subscribe to this channel. That would be much more motivation for me to make such videos in the future. For do share this particular video to your friends and colleagues and your network, close networks, and do share your feedback in the comment section about any topics you want to cover, or any things that I can improve on in this particular video. Do share your thoughts in the comment section. Thank you all for joining.